And finally, we have the absorption process or the absorption technologies. And for sure, according to the characteristics, it is the most used method for industrial dehydration of natural gas when we are talking to transmission or transportation of natural gas. We are not talking about natural gas to be liquefied and for other applications. We are talking about the natural gas to be transported. So the liquid desiccant dehydrate a liquid desiccant is used to absorb the water available in the stream, and this process is very simple to operate, to maintain. Usually we use a glycol to do that, and it can be a DEG, it can be a TEG or a TREG, and the most common is TEG because its characteristics. It has a higher boiling point, and because of that we can regenerate the TEG better, and it has the characteristics of the selectivity of the TEG is better than the DEG and the other one. So it's very common to use TEG instead of the others glycol. And using the absorption technology, we can reach the dew points up to minus 55 Celsius degree. So as my process is minus 39 Celsius degree, it is higher than minus 65, so it's okay to my process. And here, just to let you know, there is a chart available in the GPSA electronic data book where we can see the correlation or the correlation between the purity of our TEG system and how much it can reach in terms of dew points. So, for instance, I need to have the dew point of minus 40 Celsius degree or minus 40 Fahrenheit degree. So if I use a TEG with purity of 99.9, or if I use a TEG of purity 99.995, I have this range of operation and I can reach the desired dew point at my product. And here I have in the presentation a simplified the process description. I will not read that because I will show you the process, a process flow diagram or a schematic related to the TEG system. So it is very similar to the condensation system. We have, in this case, we have the wet gas entering absorber tower, and before entering the tower we should have a separator vessel or a knockout drum, or in the absorber tower we can have the inlet scrubber, and the inlet scrubber in this case in fact is a vessel separator because we don't want free water going into our process. There is a demister to do the elimination of the mist or small drops of liquid going to the absorber, and the gas goes from the bottom to the top of the absorber, and the glycol or the TEG goes from the top to the bottom, and with this contact between them, the glycol removes the water and it goes to regeneration, because here we are operating at the operating pressure, and as much higher the operating pressure, better to the absorbent because it gets more efficiency. But to do the regeneration, we need to do that at lower pressure as we have in the adsorption. When we depressurize the glycol, it releases the parts of the contaminants that are available that was absorbed, and to eliminate and regenerate the tag fully, we need to add heat. So that's why we send the rich tag, and the rich tag means that it is rich of contaminant. We send that to a small column, and we have a reboiler that adds heat to the system, and we vaporize the water, and it is removed and vented from the column. Depending on the characteristics of your gas, if it has BTEX at its content, and BTEX is benzene, toluene, ethylbenzene, and hexene, the tag will remove that from your stream, and it will be released in the reflux column. And depending on the regulations of the location and the quantity of gas that you are processing, you will not be able to release that to atmosphere. You will need to have another unit to treat this gas. But it depends, as you can see, it's optional, and it will depending on the location, how much gas is available, the concentration of the contaminants, and something like that. And what we have here, once the glycol or the tag is regenerated, we have a series of heat exchanging energy efficiency, and we need to pump up again to the process because we are at low pressure, and we need to send the glycol again to the high pressure part of the system. And with this, we have the regeneration, the removal of water, and because of the characteristics of the process, time to time we need to add a tag to the system because we have little losses in the process. And just for a matter of curiosity, as during the absorption, we also remove part of the hydrocarbons. With the part of that is absorbed by the tag. So in some cases, we add a schema in order that for following up the line, we have rich tag here. We have some preheating, and we send the tag to our intermediate pressure operation in order that it can release the hydrocarbons that was absorbed by the tag. And with that, this gas is rich in hydrocarbons, so we can, if we add a compressor, we can return that to the process, or for instance, we can use that as fuel for our reboiler, and of course that it will depend on the composition, but it's a way to not lose too much hydrocarbon during your operation. See some picture related to the tag process, and here this one is from Schlumberger catalog. So here, this skid here is the regeneration skid. It is where the tag is regenerated, and the absorber column is this one here, and here is where the gas is dehydrated, and the tag goes to the regeneration, and we have the small column where there is the release of the water content. Here we have another picture of the skid, and in this picture what is most important to us is the dimensions of the skid, and of course it will depend on how much gas it can process. But when we are doing plant design, we need to know the dimensions of the skid in order to evaluate the location where we install it, how far it must be from other operating units, and etc. So that's why we have this information here.